Hello friends, welcome to the new lecture on rapid prototyping, which is unit 5 of the subject manufacturing process 3. So friends, today we are going to see a new topic actually in this rapid prototyping, and it is also the last topic of this unit of rapid prototyping. Now we are discussing here about the hybrid machining processes. Now hybrid, you come to know the word meaning of this word. Hybrid production or hybrid manufacturing is a combination. It is a combination of processes or machines in order to produce the parts in more efficient and productive way. So it is a combination of processes or combination of machines to produce the part for efficient and productive way. Now here you can see one summation here. The general object of hybrid manufacturing is 1 plus 1 is equal to 3. That is what? That is meaning that positive effect of hybrid process is more than double of the advantage of single processes. That's why it is written as 1 plus 1 is equal to 3 effect. That means positive effect of hybrid process is more than double the advantage of single process. So this is the important objective or the objective of hybrid manufacturing. This hybrid can have several meanings. Those meanings are, it may be combination of different active energy sources which act at the same time in the processing zone. For example, if you take the example of laser assisted turning, or the processes which combine process steps that are usually performed in 2 or more process steps. That is, the combination of 2 or more process steps is also known as hybrid machining process. So what are the meaning indicates? Either it is a combination of different active energy sources which are acting at the same time in the processing zone, or it is the combination of 2 or more processes. It is also known as hybrid machining process. Now let us see what is the classification of hybrid machining processes. So hybrid machining processes are classified as combined or mixed type process or assisted type process. Now, combined or mixed type process means all the constituent processes are directly involved in the material removal. That means in this type, all the processes are involved in the material removal. But in case of assisted type processes, there is only one participating process directly remove the material, while the other processes assist in removal. Understood this? Combined or mixed type means what? All the constituent processes are directly involved in the material removal. But in assisted, only one process is involved for directly removal of the material, while the other processes assist only in removal by having the positive effect on the conditions of machining. So this is how these hybrid machining processes are classified: combined or mixed type and assisted type. Now here you can see one chart here. Here you can see the hybrid processes. It is combination of different energy sources and controlled application of processes. Now again, this combination of energy sources is divided in assisted processes and second one is mixed processes. One is assisted and another is mixed. In assisted processes, you can see over here laser assisted turning, vibration assisted grinding, vibration assisted EDM, media assisted cutting, laser assisted bending. So these are the again classifications of assisted processes. And the mixed processes involve EDM or ECM, curved profile, extrusion. So this combination of different energy sources or tools is subdivided into assisted and mixed processes. And again, there is a list of assisted processes and also the mixed processes. But in this second case, controlled application of processes involves grind hardening, combination of removal and forming, stretch bending combined with single point incremental forming. So in this how these hybrid processes are classified. Now coming to first one, assisted hybrid processes, in which vibration assisted hybrid machining process. Now you have seen the grinding process. So vibration assisted grinding means what? Vibration assisted grinding is rather a new technology where superposition of conventional grinding and vibration is established. That is the combination of, you know, the grinding process. In grinding process, how the material is removed. In here, vibration assisted hybrid machining process or vibration assisted grinding, it is a combination of your simply conventional grinding and vibration. Both are combined together. That is known as vibration assisted grinding. Now here in this case, you see the positions. So this is a figure, this is the diamond tool, this is the workpiece, actor with piezo actuator, and here you can see side grinding and peripheral grinding and the grain movements for both these grinding processes. So remember at this stage is vibration assisted grinding is a combination of simply your conventional grinding and vibration. Now vibration assisted EDM. So in vibration assisted EDM, what is done? An additional relative moment is applied in the system tool electrode, workpiece and dielectric fluid in order to increase the flushing efficiency, resulting in higher material removal rate and better process stability. So electric discharge machining you already learnt about. So here it is assisted with the vibration process. Now what is done here, or what you will get when you assist with the vibration to increase the flushing efficiency. The flushing is most important parameter of EDM process. So if you increase the flushing efficiency, it definitely results in higher material removal rate and better process stability. So in micro EDM also you have learned process. What is there? Flushing conditions and discharge gap have been identified as the main influences. So in micro EDM, what are the influencing factors? Flushing conditions and discharge gap. So if you improve the flushing strategies and optimize the discharge gap, that will lead to the great improvements. So micro EDM has that problem or the influence of flushing conditions and discharge gap. So if you improve this both, that is flushing strategy and optimize discharge gap, you will have a great improvements. And also you can see the periodic relative movement between tool and workpiece causes flow of dielectric and an agitation of debris particle in the dielectric medium. So these debris particles will be agitated, or agitation of debris particles in the dielectric medium. And due to what? Settlement of debris and agglomeration of the particle, and the state of gap is equalized. So what is there? The periodic relative movement between tool and workpiece causes flow of dielectric and also agitation of debris particles in the dielectric medium. Due to this phenomena, the settlement of debris on the bore ground and the agglomeration of the particles are reduced. Due to this, what happens? Debris settlement and agglomeration is reduced and state of gap is equalized. So in micro machining, the main influencing factors, flushing conditions and discharge gaps, and due to this periodic relative movement between tool and workpiece, which causes a flow of electric and agitation of the debris particle in the dielectric medium. And due to this phenomenon, what happens? Settlement of debris on the bore ground and the agglomeration of particles get reduced and the state of gap is equalized. This is the figure of vibration assisted EDM, where this is here you can see this y-axis is for electrode wear rate, and in the no vibration condition, this is the no vibration condition, see the electrode wear rate is high. In electric vibration, again this is electric vibration and this is fluid vibration. So electric vibration you are finding the electrode wear rate is less. It is more in case of no vibration, and it is up to certain mark in the fluid vibration. So this is vibration assisted EDM. Now next part is ultrasonic assisted ECM, electrochemical machining. You have learnt about the electrochemical machining. So what is there? Electrochemical dissolution and the formation of passivating oxide layer occur on the workpiece. By ion formation and the moment within the electrolyte, producing a high intensity current flow. So this passivating layer is removed by ultrasonically accelerated abrasive those impact on the workpiece surface. So this process helps to maintain constant inter-electrode gap. So you have learnt about the electrochemical machining. So in ultrasonic assisted electrochemical machining, what happens? The passivating layer is removed by ultrasonically accelerated abrasive which impact on the workpiece surface, and that helps to maintain inter-electrode gap. Here you can see electrode and the abrasive, and this is the workpiece, and due to this ultrasonic assisted ACM, it helps to maintain constant inter-electrode gap. So the second part is the heat assisted HMPS. Heat assisted HMPS. The use of an external heat source improves the machinability by minimizing the machining force, improving the work surface integrity, and enhancing the tool life. So whenever you use the external heat source, it improves the machinability. How it improves the machinability? By minimizing the machining force, integrity, and enhancing the tool life. This heat source may be in the form of laser beam, electron beam, plasma beam, high frequency induction, or electric current. So you can use any of the heat sources mentioned over here, either laser beam, electron beam, plasma beam, high frequency induction, or electric current. So laser assisted machining is one of the most important and most widely used category. Now laser assisted HMPS are of two types. One is laser assisted mechanical machining, laser assisted advanced machining. In case of laser assisted mechanical machining, laser is used to heat the workpiece ahead of the cutting tool during conventional machining process such as turning, milling, and grinding. Here in this case, laser is used to heat the workpiece ahead of cutting tool. So where the portion where the cutting tool cuts or cutting tool touches, that portion prior to that cutting tool, that is the area in front of the cutting tool, is heated by the laser during this laser assisted mechanical machining such as turning, milling, and grinding. And laser assisted advanced machining, here laser assistance enhances the material removal in electrolytic dissolution and electro discharge based AMPS, advanced manufacturing processes. AMPS, advanced manufacturing processes. So laser assisted HMPS, two types are laser assisted mechanical machining and advanced machining. In mechanical machining, what happens? Laser is used to heat the workpiece, that is the portion of the workpiece ahead of the cutting tool, which helps for the easy removal of the material. And in laser assisted advanced machining, it laser assists, enhances material removal in electrolytic dissolution and electro discharge based AMPS. Now we'll see one process, laser assisted turning. Now this is general turning picture. Here you can see the tool, and this is the workpiece, and this is the conventional turning or turning process. Here laser is used. Why laser is used? The main material removal mechanism is still one occurring in the conventional cutting. So main mechanism is just like cutting the material as in case of the turning operation. But laser action, the laser here, as I told you earlier, laser is used ahead of the tool, means here in this area, what if you use the laser, what will happen? The laser action softens the workpiece material, so machining of high alloyed steels or some ceramics becomes easier. So normally if you go for the conventional cutting, if you use the alloying steels or some ceramic materials, it will take more time due to hardness of that alloying material and ceramics. So it will take time and it will become bit difficult for turning operation. But if you can use laser, what will happen in that case? It softens the material. The laser softens the material, and This will help to remove the material faster and easier, as in the case of alloyed steels or some ceramic materials. So what it does, the laser beam is directly focused in front. Now here is the cutting tool. So laser beam is focused in front of the cutting tool. That's where that portion becomes softer, which results in easier machining and higher process performance. So that's why it is assisted with the laser simple turning operation. If you go for the alloy steels and ceramics, you will find some difficulty, or if you can find difficulty for removing the material due to their hardness. But if you use the laser, what will happen? It will soften the workpiece material and helps in easy machining and higher process performance. This is how laser assisted turning operation. Now in case of laser assisted ECM, electrochemical machining, or it is also called as LAECM. LA is laser, ECM is electrochemical machining, laser assisted ECM process. Now here in this case, the primary role of laser in ECM is to improve the localization of dissolution process. So dissolution, it is the localization of dissolution process. The main mechanism of material removal in LAECM is enhanced by electrolytic dissolution because of an improved thermal activation brought upon by focused laser beam. Here, this is general process. Here you use the laser beam. What it does? It helps localization of dissolution process. How? By electrolytic dissolution because of the improved thermal activation. So additionally, it also helps in removing this metallic oxide layers due to evolution of the oxygen at the anode. What happens in general ECM process, there is a metallic oxide layer formation. So that will be removed from the workpiece due to evolution of oxygen at the anode during electrolysis process. So you have understood that ECM process, ECM and electrolysis, it is assisted by the laser, and this laser, what it does, it improves the localization of dissolution process and also remove the metallic oxide formed due to evolution of the oxygen at the anode during electrolysis process. This is how the laser will help or assist in ECM process. Now EDM, you all know how EDM works. So laser assisted EDM, it is also known as LAEDM. Now what are the drawbacks of the EDM process? It will take more machining time, and also there is a high rate of tool wear. And what are the laser drawbacks? Formation of recast layer and heat affected zone, HAZ, and low surface quality of the workpiece. So these are the drawbacks of EDM and the laser. So EDM will take lengthy machining times and high tool wear, while laser have low surface quality and formation of recast layer and heat affected zones, or HAZ heads. So what is the solution? So the hybridization of LBM, laser beam machining, and EDM as LAEDM. So it is the hybridization of laser beam machining and also EDM. So if you take separately LBM and EDM, those drawbacks are mentioned here. If you simply take EDM, it is the lengthy machining time and high tool wear. And in case of laser beam machining, there is a formation of recast layer and also heat affected zones and low surface quality. Now what is the solution? There is a combination. There is a combination means hybridization. Hybridization of what? Laser beam machining and EDM, which is called as LAEDM, addresses their respective disadvantages. That means this hybridization will help to remove the disadvantages. So LAEDM is generally used in micro machining application of reducing production time and eliminating the recast layer and HAZ caused by laser ablation. So if you hybridize, that is the combination of these two processes, generally removes the disadvantages if you use this LBM and EDM separately. So this LAEDM, which is used in the micro machining application, it also reduces the production time, also eliminate the recast layer, and has caused by laser ablation. Here you can see the pictorial picture of LAEDM. Here you see the two picture. Here first of all is the laser beam and second one is the EDM. That is the pre-machining is done by laser ablation and second post machining is by EDM. What is done? A short pulsed laser beam which is capable of producing high ablation rate is used to roughly pre-machine the basic part of the feature. If you want to have any groove, hole or cavity, that will be done by laser beam. And this subsequently followed by micro EDM with a suitable dielectric to remove the surface defects caused by thermal effects of laser ablation and to finish features. So first of all, what is done? Pre-machining. Pre-machining by whom? That is laser beam. How it is done? If you want, first of all, the basic feature parts are done with the help of laser beam. That if you want a groove, hole, cavity, that is roughly pre-machined is done by laser beam, which is capable of producing high ablation rates. And once this is over, then next it is followed by micro EDM. And now what micro EDM does? This micro EDM with a suitable dielectric, it removes the surface defects. That means after laser beam, whatever the surface defects caused by thermal effect, due to laser there will be heat, so there will be heat means thermal, and if you use this laser beam process for the groove, hole, cavity, there are the chances of thermal effects of laser ablation. So in this micro EDM, what it does, it removes the surface defects which are caused by thermal effects of laser ablation and to finish the features. So it is the combination of laser beam and also EDM. So it is known as laser assisted EDM. Primer or pre-machining by laser ablation. If you want any groove, hole or cavity, you can go for the laser beam pre-machining laser ablation. Once it is over, it is then post-machined by EDM process, where whatever the surface defects caused by the thermal effects are removed and final finished features are done. So the third part is magnetic field assisted machining processes. So magnetic field assisted HMPs. Now here the word magnetic field itself indicates you are using a magnetic field. So magnetic field assisted HMP rely on the enhancement of primary machining and finishing process by addition of magnetic field with the aim to improve the workpiece surface quality and material removal rate. Here, what is the meaning of this? That is primary machining, whatever the machining or finishing you are doing, in addition to that, you are taking the assistance of magnetic field. Now, what is the use of this magnetic field? It will improve the workpiece surface quality and also material removal rate. So magnetic field assisted EDM and magnetic field assisted abrasive flow machining. These are the two processes where you can have the assistance of magnetic field. So EDM process, which is assisted by magnetic field. In the last slide we have seen laser assisted EDM. Here the same EDM which is assisted by the magnetic field, and also abrasive flow machining, AFM. It is the abrasive flow machining assisted by magnetic field. Now magnetic field assisted EDM, MAEDM. Now what is this process? So in general EDM process, debris accumulation in the machining zone always have the adverse effect on the performance and efficiency. So this EDM has the main disadvantage of debris accumulation, and unless and until this debris accumulation is removed, definitely there will be adverse effect on the performance and efficiency, which is the main problem of the EDM. So how to overcome this situation? To overcome this situation, that is debris accumulation, magnetic field is added in this EDM process. By adding the magnetic field, what will happen? It will enhance the process stability and increases the efficiency of EDM component by effective removal of machining debris from the machining zone. So the main disadvantage of EDM is debris accumulation in the machining zone, which affects the performance and efficiency. If you add the magnetic field to this EDM process, this will definitely give the stability to the process by effectively removing the debris from the machining zone. See here, magnetic field assisted EDM. Here, as I told you earlier, debris accumulation is the main problem with the EDM process. Now here in this case, there is an introduction of the magnet. Here the magnetic field is introduced. So magnetic field is introduced. This is the rotational disk and this is the debris. Now this is the magnet and this magnet produces this magnetic field. So the introduction of magnetic field exerts a magnetic force. Due to this, magnetic force is perpendicular to electrode's motion. Perpendicular to the electrode's motion. This is the two electrodes, and magnetic field, when magnetic field is applied, the magnetic force acts in the perpendicular direction to this tool electrode. So what will happen? These debris particles are subjected to magnetic and centrifugal force. Centrifugal force, you know, the force which is acting away from the center, and this debris which is accumulated, here, it is now subjected to both the forces. One, the force of the magnetic force created by this magnetic field, and also the centrifugal force. And due to that resultant force, which is the nothing but the vector sum of magnetic and centrifugal force, which ensures effective and rapid flushing of the debris particles. Now this is how this process works. That means due to the addition of the magnetic field, magnetic forces are produced, and this is the debris. In general EDM process, the debris is collected in this machining zone, which has to be overcome or to be removed for the efficient process. But if you know how that is done, by using magnetic field assisted process. Now here is the magnet, and due to this magnet, magnetic field is produced, and due to this magnetic field, magnetic forces are created, and now these debris particles are under two forces, subjected to two forces. One is the magnetic forces produced by this magnetic field, and also the movement of these centrifugal forces. And due to these two forces, what will happen? That is the vector summation, that is due to these forces. So rapid and effective flushing, that is the removal of this debris particle, and which will improve the efficiency of the process. The second case is the magnetic field assisted abrasive flow machining. Now here what happens? Magnetic field assisted abrasive flow machining, or what is also called as MAAFM, is an important hybrid abrasive flow machining process where assistant of magnetic field provide the means of controlling the cutting forces, and consequently the outcome of the process includes higher surface finish and finishing rate. Here also, due to the application of the magnetic field, what will happen? It will provide means of controlling the cutting forces, and consequently the outcome of that very good or high surface finish and very good finishing rate. And the process is capable of producing surface roughness as small as 8 to 10 Nm. So this is the rotating magnetic pole, and this is the ferromagnetic abrasive, due to which there is a magnetic field is produced. This is the north pole, this is the south pole, is no magnetic. These are the magnetic lines of the forces, and which will help for higher surface finish and finishing rates. So friends, today we have seen about this hybrid manufacturing process. So in the next lecture, we will see some more hybrid manufacturing processes. Till then, take good care of your health. Stay home, stay healthy. Thank you very much.